All right, friends, welcome to our instruction video on getting ready to succeed on that plate tectonics poster. We're learning about the Earth now and how it moves and why we have the natural disasters that we see about, experience and see in the news. And how do we know what we know about the Earth? How do we know the Earth is changing? Even though it's moving so slowly, we can't actually stare at it and see any difference. So let's start with what we do know, what we can see. And if you remember what it was like that morning in March 18th, that earthquake that woke us all up, that is one of many little hints that lots of changes are happening deep in the earth. So earthquakes, obviously volcanoes, landslides, when things get shaken loose, the weakest parts can collapse and we get a landslide. Fault lines, like our own fault lines running through here in Utah, and then the really, famous ones like the San Andreas out in California. We'll talk about some of those today too. And mountain building, what's strong enough to make mountains grow taller, right? What is mighty enough to make that happen? And why do all of these things even occur in the first place? And they're still happening. Shouldn't the earth have settled down by now? Let's take a look. Let's explore this ideas. Okay, so we're going to take a journey. This is the journey we're going to take to succeed on our journey today and make sure you have exactly what you need for the poster I'm going to have you build. That is assignment in Canvas number 2.6, Plate Tectonic Boundaries poster. Make sure you have a piece of paper and a pencil today. You'll see some words in green on the screen there, in the slides ahead. And we're going to learn about 4 people today and the journey that we made to learn all those interesting things about the Earth. So grab your paper, grab your pencil, grab the green words when you see them, and let's begin. It started with observations. It started with empires and kingdoms wanting to have maps of their territory. And then it led to ideas. Whoa, look at these maps. Looks like parts of this land that are now apart used to be together. That's an idea. Hypothesis, educated guess. Well, if these pieces of land used to be together, but they're not now, they must be moving. That's an educated guess. And then the scientific theory explains why and where the movement is actually taking place. So, again, it started with an empire. Take a look at the Roman Empire here. Pretty amazing, empire of its day, right? 2,000 years ago. It just got bigger and bigger and bigger, took over most of Europe, North Africa, parts of the Middle East. It was pretty impressive. And in the beginning, maps focused only on the empire, the kingdom, right? But after a while, people wanted more than just their own land. They wanted bigger pieces of land, right? They wanted a bigger view of the world. And you can see here the top of Africa. You can see Europe, obviously, in very good detail right there. You can see the Middle East, right? You can see India shown as an island. So they weren't perfect, but they're thinking bigger. That's good. Eventually, a map maker named Ortelius decided enough of this one continent or 2 continents thing. I'm going to map the whole world. And here he is. Abraham Ortelius is the first character, the first person in our big story. So, may I have you go ahead and grab the green, pause it if you need to. Abraham Ortelius gave us our first modern atlas in the year 1570. He imagined a supercontinent because he noticed how Africa and South America fit together pretty perfectly. And he said, well, if they fit together, they must have been together, and now they're not. And they said, great map maker, great cartographer, why aren't they together anymore? And he said, it must be they were torn away in violence, ripped away in calamity and misfortune, and eventually they stopped where they are today. And that was his explanation. And they're like, oh, okay, must be real, must be good. So they allowed that explanation to keep, and it became a matter of interest, but they didn't give it any further thought really until a couple hundred years go by. Okay, and we bring in the second person in our story today who takes an idea of a supercontinent. Sorry, my nose is itching. Weird. And he took an idea and turned it into an educated guess. Take a look at the map he was looking at. This is Ortelius's map. And he noticed, like Ortelius did, how Africa and South America looked like they fit together. Pretty cool. Well, if those two fit together, what if all of them were once together? Ortelius said, yeah, supercontinent. But it was Wegener who gave it a name. I mean, check it out, right? He suggested that the supercontinent be named Pangaea. He's the one who gave us that cool name. This is Alfred Wegener. Now, he was not a geologist. He wasn't an expert in the Earth. He was an expert in climate. He was an expert in weather. Meteorology was his specialty. So while he had solid ideas about the Earth, the geologists of the time dissed him and dismissed him. They didn't want to hear anything he had to say because he wasn't one of them. I think we can all relate that it's easy for people to reject someone who is not part of their in group, their in crowd. Does that make it right? No, of course not. Because his ideas were correct. His ideas that the continents were not ripped away in violence and then stopped, but that they slowly moved apart from each other on the surface of the Earth, and they're continuing to move to this day. That's a tough thing to prove, because you can't just set up a camera, take a picture, go back 2 weeks later, take another picture and go, wow, look, the whole continent of Africa moved. It's so slow we can't see it. That's the challenge. So he brings his ideas and he brings his evidence. Let's take a look at his evidence and see what he shared with the geologists of his time. Check it out. So he said, obviously, everyone can see Africa, South America, they fit together. Anybody, it's obvious. And they all went, okay, we got it. We see that. He also brought back fossils of dinosaurs that matched in Africa and South America, right? He could see and compare and show, look, this is the same dinosaur, and it could not have swum across an ocean. It would drown in the first minute. It's a land dinosaur. It couldn't swim. But here it is on both sides. And they said, oh, there must have been land bridges. And Wegener said, where are the land bridges now? And they said, well, it's better than your silly idea that the whole continents are moving. What are they, floating on the water, Mr. Meteorologist, Mr. Weatherman? And he said, no, of course not. They're not floating on the water. And he said, well, where are they moving? And he said, I don't know. He said, why? And then they challenged him again. Why are they moving? What is moving an entire continent? And he said, again, I don't know. But the evidence is clear. They're slowly moving apart. And they said, yeah, we don't believe you. So the rock layers matched in different parts of the world separated by oceans. Okay. He dug up ferns and palm trees from the parts of the world that have been frozen for hundreds of thousands of years. Antarctica. You dig down in the ice, you find ferns that only grow where it's tropical, like swampy and hot and, steamy, that kind of thing. Or palm trees in Iceland, right? Palm trees don't grow in Iceland now. They don't even grow in Salt Lake City now. But they did back then when those land masses were in tropical areas before Pangaea broke up and scattered all over, right? And parts of it got cold and froze. Parts of it stayed in the warm parts, and then we have the world we have today. So he had all these facts. And was he wrong? Was he wrong about this just because he couldn't explain why? No, his educated guess was correct, but he couldn't prove it. So, wind the clock forward again. His idea of continental drift. Okay, remember from the last slide, I'll back it up really quick. He was unable to explain why continents drift. Underline continental drift for me, continents drift. That was his baby, his big idea, continents drift. Okay, he had all these facts. They didn't believe him because he couldn't explain where and he couldn't explain why. Let's take a look at who gave us the where. Okay, so these two individuals, mainly Marie Tharp. Bruce Heason was sort of just along for the ride. He needed to be convinced. Marie did the studying of these scans of the ocean floor and found that if Wegener had looked a little deeper under the ocean, he would have found the evidence he was looking for, because she found it. She said, man, Wegener was looking at the dry land part. Picture it, okay? Picture it right now. The dry land here, Africa. The dry land here, South America. Wegener thought these were the parts that were moving apart. He didn't realize that under the ocean, at the bottom, there's mountain ranges and valleys. So take a look at my hands here. They show this part deep. Again, the dry land is up here. Go under the ocean, right? It's not flat all the way across. That was a mistake to think that the bottom of the floor is flat everywhere. Not the case. It's broken. It's got mountain ranges. More importantly, it has a valley running down the middle where the pieces of land are pulling apart. See that? Underneath the bottom of the ocean is where the movement actually begins. And the rest of the ocean floor is along for the ride, and the dryland continents also going along for the ride. So now we know where, at those mid-ocean ridges, that's where the ocean crust, the rock under the water, is pulling apart like that. Okay? Now, so we know where, and they produced this map to show where. Look at that. I learned in third grade 7 continents, right? North America, South America, Africa, Asia, Antarctica, and Australia. So that's 7. Okay, we got our 7 continents. Well, that's not all of the pieces of the Earth's crust. There's another 8 or 9 of them covered in water. Take a look at this picture. Everywhere you see a border, right, an edge, including the one starting right here at the tip of my finger, right, and it wraps its way up, around, down the coast, and out into the middle of the ocean. Every one of those pieces over there is another chunk of the Earth's crust that we didn't learn in school, because they're not places we can actually visit. I don't know about you, but the last time I was at the bottom of the Pacific Ocean, you see what I mean? It's not in our experiences, so we don't bother learning about it. But it's there. Take a look. It's right there. 15 or 16 pieces of the Earth's crust, not just 7 continents. That's huge. Now you're seeing the world as it really is. And this map, 1977, okay, is the best one of the ocean floor that has ever been made then or since. Remains, to this day, the standard. I have a copy of this map in the classroom. Some of you who have already seen it, others of you, if you visit the classroom, give me a moment to show this thing to you. It'll blow your mind. It's really cool. I got like a three-dimensional version. Okay, so Tharp and Heason, with this map, showed us where the continents are moving. See those ridges? That's where this moving, this spreading apart is actually happening on the ocean floor. But why? Why? I took another researcher, this guy, Captain Harry Hess, to show us why. I give you convection in the mantle. So he's also looking at the ocean floors. And he's not just seeing the rock underneath the ocean, right? He's thinking of the layers under that and under that and under that, all the way down to the Earth's core. That's Harry Hess's mind. He's seeing the layers of the Earth down to the core, where some parts are hotter than others. So if some parts are hotter than others, that's where the heat rises up, right? Hot air rises on a cold day. Hot parts of your soup will boil to the top in a pot of soup. We call it convection, okay? So he imagined convection in the layer of the Earth just under the crust, the mantle, okay? And mantle convection must be what's moving the continent around. Harry proved that Alfred Wegener was right, and he gave it why. He gave it the piece that Alfred Wegener was missing. Check it out. Watch this in. So make sure you have the green. Grab the green for your notes. If I move too quick for you, pause it if you need to. Here we go. Look at the heat rising off the core. Okay? Rises up to the surface from the core, the hottest parts of the core. Pushes slowly. This is a very slow process. In this animation, it's sped up really fast. Look at the pieces of crust on top that are along for the ride. The thinnest bits are those mountain ranges and rift valleys on the ocean floor. That's where it's really thin because it's being stretched apart. This part of the land and this part of the land are being pulled apart from each other, and the magma, some of it fills in the gaps there and makes those mountains. Well, the continents under the ocean and the dryland continents on the edge of the oceans are being moved apart. When you go back far enough, they were being pushed together because they were being moved apart on the other side of the planet. But then the forces continued and Pangaea got ripped into pieces. Check out Pangaea coming apart at the seams. Look at that. Africa and South America separate from each other and everything's spreading out all over the globe. Wind it back to the beginning now. Now, look at Antarctica. Used to be green down there. Check it out. Used to be green, then it moves to the South Pole and turns frozen. Back it up. Look at Australia. Used to be sideways, and then it moves and kind of turns in an orientation we know it is today. Look at India moving up. Watch India. Used to be an island. It's the big one next to Africa, not the little one, but the big one. There it is, an island moving north and eventually collides with Asia, right? And two land masses that are being pushed together by the forces deep underneath the crust, pushed together, making those mountains get taller and taller. Mount Everest, for instance, in the Andes Mountains, in the Himalayas, are getting taller by an inch or two every year. That's a lot of force to lift an entire mountain chain up every year, constantly, because India and Asia still colliding to this day. So parts of these borders pulling apart, other borders pushing together, some of them grinding past each other. That's what the Earth is doing. That's why we have our earthquakes. That's why we have our volcanoes, right? So those are your notes I've had you take today. And that's the world we have today. You can't actually see the world changing before our eyes because it looks like everything's standing still. But it is moving. There will be another supercontinent in the future, just as there have been 4, maybe 5 in the past. Okay? And how do we know all these things? This is the journey we took today. Let's recap really quick. Emperors and kings wanted their maps of their kingdoms, but eventually Ortelius makes a map of the whole world. And he comes up with the idea. What if Africa and South America used to be together? They look like they fit. Cool. Along comes Wegener and says, yeah, Ortelius, I bet you're right. And they were together, okay? And they moved apart slowly, not quickly like Ortelius said, but slowly they're drifting apart. And the other geologists are like, Wegener, you don't know what you're talking about. Tell us why. And he's like, I don't know why. And they said, okay, can you tell us where it's actually pushing apart? And he says, I don't know that either. Thorpe and Heesen give us the map of the ocean floor, and now we know where. Harry Hess comes along and gives us his theory of seafloor spreading, where the bottom of the ocean are being pulled apart, convection in the mantle doing that moving, that force behind everything moving. And now we have why. In the end, the result is our theory of plate tectonics. There it is, in a nutshell, everything you need to succeed on that part of your tectonics poster. So, the green words you wrote down, keep those. You'll need them, okay? To add a paragraph to your poster, which is assignment 2.6, plate tectonics or tectonic boundaries poster, okay? So go to Canvas, pop open 2.6, use this video, this lesson that I gave in class before we broke up for winter holidays. Use the green words to write each step of that journey. 4 sentences at least, 5 or 6 would be better to capture what you put in your notes. Put them in full sentences, and you'll ace this part of your poster. So when you're done here with this video, immediately please go to 2.6 if you haven't already, and make your poster happen. Okay, you can do your poster on separate pieces of paper at home, or you can use the big poster piece of paper that I provided in class. Your choice. So make that poster happen, follow the directions in the assignment, and you'll be right as rain. Okay? Let me know if you have questions. Shoot me a message in Canvas or shoot me an email, and I'll respond back and do the best I can to clarify. Okay? Can't wait to see you all again. Hope you're doing well. Hope everyone is happy and healthy in your family, and take care of yourselves in the meantime. We'll talk some more soon.